Did you know the largest planet in our solar system doesn't actually orbit the sun the way you were taught? It sounds wrong at first, almost like clickbait. But it's not. Because the truth is, far more interesting than the simplified version we all learned in school. We grow up with a clean picture in our minds. The sun sits perfectly still, glowing at the center, and every planet moves around it in neat, predictable paths. Simple, logical, easy to understand. But nature rarely chooses simple. Let's rewind history for a moment. In the early 1600s, Galileo Galilei made a discovery that changed everything. He observed tiny objects orbiting Jupiter. That alone proved something radical. Not everything revolves around Earth. It was the beginning of a new way of thinking. But even that new model was still an approximation, because here's what's really happening. Gravity is not a one-sided force. It doesn't work like a boss giving orders. It's more like a negotiation. Every object pulls on every other object, always. When two objects interact gravitationally, they don't behave like leader and follower. Instead, they both move around a shared point in space. An invisible balance point, a center of mass. For small objects, this shared point is usually buried deep inside the larger one. That's why Earth appears to orbit the sun, because their balance point is located well within the sun's interior. So visually, nothing seems unusual, but Jupiter changes the game. Completely. Jupiter isn't just another planet. It's a giant that dominates everything around it, more massive than all other planets combined. A true heavyweight of the solar system. Because of that mass, something unexpected happens. The shared center of mass between Jupiter and the sun shifts, not inside the sun, not at its core, but just outside its surface. Floating in space, that means something mind-bending. The sun itself is not standing still, it's moving, slightly wobbling, tracing a slow, looping path, pulled by Jupiter. And Jupiter? It's not orbiting the sun directly, it's orbiting that shared point, that invisible anchor in space. So technically speaking, neither of them is orbiting the other in the way we imagine. They are both orbiting something else. Together. If you could step far outside the solar system and watch this from a distance, you wouldn't see a perfect, centered system. You'd see motion everywhere. The sun drifting, Jupiter pulling, a subtle cosmic dance unfolding over millions of years. And this idea doesn't stop with Jupiter. Every planet contributes to this motion, even if only slightly. Saturn, Neptune, even Earth, they all tug on the sun. Jupiter just happens to be strong enough to make the effect obvious. This reveals something deeper about the universe. There is no absolute center, no perfectly still object, no true anchor. Everything moves, everything responds, everything is connected through gravity. Even stars far beyond our solar system behave this way. In binary star systems, two stars orbit a shared center. Sometimes that point lies in empty space between them. Sometimes one star dominates, but the rule is always the same. Mutual motion. So when we say planets orbit the sun, we're not wrong. We're just simplifying. We're smoothing out the complexity to make it easier to understand. But once you look closer, the illusion breaks, and what replaces it is something far more beautiful. A system where nothing is truly fixed, where even the most massive object is influenced by something else, where balance is constantly shifting. And suddenly, the solar system feels less like a diagram and more like a living mechanism. So next time you imagine Jupiter circling the sun, picture this instead. Two massive bodies, bound by gravity, moving together around an invisible point in space, neither fully in control, neither completely still, because in the universe, motion is never one-sided. And here's something to think about. If even the sun can be pulled off center, what does center really mean in a universe like this? Space know-how. See beyond the simple version.